Hello, my name is Jake,
I'm Joel.
I'm Luke.
I'm DJ.
and we're the plastic injection molding group. Montana State University recently purchased this German-made plastic injection molding machine. The goal of our Capstone project is to implement plastic injection molding into the Montana State Mechanical and Industrial Engineering curriculum.
So first we're going to go over some basics of this German-made Boy 22S that MSU recently purchased. We have a little protective cover here. And then our fit system is going to slide in here and bolt one side to here, one side to here. You're going to have your two mold halves are going to sit inside of that. Then over here we have our hydraulics that run the ejector plate, which ejects the part after it's been dried or solidified.
And then next we have the hydraulics here. These hydraulics run this back plate that will close and clamp the two mold halves together. So once those are held together, you will have plastic from this hopper here running down into this auger through a heating element. So your plastic will be melted, and then through this sprue it will be hydraulically forced into the mold, held, and then the part will allow cooling for the part, and the hydraulics will open and eject the part and then close again and repeat the process.
Plastic injection molding involves many process variables that can be adjusted, including injection temperature, injection time, injection pressure, and the amount of time that is allowed for the plastic to cool. They are all controlled on this dial board here, and this will be worked into the curriculum. Students will have the opportunity to adjust these variables for two different plastics, polypropylene and polystyrene, until each plastic fills the mold in an optimal manner.
For our project, we chose to make two different parts. We chose the first being this fly fishing nail modder tool, the second being a single carabiner. We chose these two parts because they have similar wall thicknesses but distinct geometries to show how molding changes. These settings will be able to be changed on the dial board, which was shown previously. Depending on both the material and machine parameters, the mold will either fill or have voids, and each material will have different characteristics which the students will be able to explore.
SolidWorks simulation was used to analyze our mold half. It was fixed on either side of the rail here, just like it will be fixed in the machine. A 25,000 pound per square inch force was applied to the entire mold cavity, which was going to be the worst case scenario for the machine. Maximum deflections were found to be right under 3 thousandths, which is acceptable for industry standards.
3 thousandths of an inch of deflection is an acceptable value. If the value was over about 6 thousandths of an inch, flashing in our mold halves would occur. That is when molten plastic escapes the cavity of the mold and gets in between the two mold halves. This can be an issue because you will then have faulty parts.
SolidWorks simulation was also used to perform stress and strain analysis on the carabiner and nail nodder. It was found that the carabiner, made out of either material, can withstand a tension force of up to 10 pounds. And analysis demonstrated that the nail nodder could withstand a bending force of up to 25 pounds.
This is the drawing for the entire mold assembly, including the ejector plate and all ejection pins, locator pins, return pins, as well as the necessary hardware to assemble the entire mold and fit system. And here are the drawings of the parts we created. This is the carabiner, drawing 1 of 3. Here is the second drawing with the necessary details for the end conditions. And here is some more radius dimensions. This is the drawing for the nail knotter.
This drawing shows our ejection plate with the necessary holes for the ejection pins. Right here are the pins that will be ejecting the nail knotter. These holes over here are going to be the pins that will eject the carabiner. The holes on the outside are for the return pins. Here's a view of our mold A side. Right in the center you can see the location of the sprue. The sprue will be machined on a manual machine. The part detail, however, will be done in the CNC mill. Final grinding will also be done. The ejection pin holes will be made using a manual machine as well.
Once the manufacturing is done on our mold, we will insert the fit system as well as our mold blanks with the parts created. We will begin production and start creating parts. Thanks for watching.